Hello my friends, this is today's math lesson. It is lesson 8, display measurement data in a line plot, and it starts on page 743. Okay, so we're still doing measurement. Today we're going to be looking though at ways to kind of analyze the measurements that we take, okay? So it says you can represent measurement data for fractions of a unit in a line plot. The line plot's number line will look like a ruler. Okay, so here's a picture of a ruler. Notice that it starts at 0, and the 0 does not go all the way to the edge of the ruler. So when you're measuring, you have to go in so that the left side of whatever it is you're measuring lines up with that 0. And you could see that this has been divided into 1/8 inches. Okay, so you see that there's 8 parts right between the 0 and the 1 inch here. Okay, so in each of these lines represents another 1/8 of an inch. Okay, so it says the science room has a collection of bugs. Each bug's length is measured to the nearest 1/8 of an inch, which is shown here. Make a line plot to represent the data. It says that the measurement data are shown in the tally chart. Okay, so this is the tally chart, and I'm not sure if you remember how tallies work, but each time you're counting something, you give it one line. Whoops, there goes my mechanical pencil. So one line, and you do 4 lines like so, and then for the 5th line, you go like this backward slash. So if you see this, that means 5. So this would be 6, 7, 8, 9, and this would be 10. Okay, so it's a visual way to represent numbers. Okay, and they measured these bugs and they did a tally for all the bugs that were 2/8 of an inch, and there were 2 of them. The bugs that were 3/8 of an inch, there was 1 of them. 4/8 of an inch, there were 2 of them, and on down. Okay, so the first thing you do when you're doing a line plot is to make a number line to represent the value of each bug's length. So you can see this number line is very similar to the ruler. It's it has the 0 and the 1 inch here represented, and then the number line is divided into 1/8 similarly to the ruler. Okay, so this is how a line plot works. You start with this number line, and then next you place an X above each measurement every time that value occurred. So we have none that were 0, obviously. We have none that are 1/8 of an inch, but look, we have 2 that are 2/8 of an inch, so we put 2 X's above the 2/8. We had 1 at 3/8, you put 1 X above that. We had 2 at 4/8, 2 X's. Okay, now look here, we have a 5 plus 1 more is 6, and above the 5/8 we have 1, 2, 3, 4, 5, 6 X's. Okay, 6/8 of an inch, we have 5, 1, 2, 3, 4, 5. 7/8 of an inch, we didn't have that slash line, so we're at 1, 2, 3, 4. 1, 2, 3, 4 X's above that, and we had 1 that was 8/8 or 1 inch. Okay, if I have 8/8 of something, that means I have 1 whole. Okay, so now we're going to refer to this page and the data that we had, and it says to find the difference in length between the longest and the shortest bug. So to find the difference between the longest and the shortest bug, subtract the shortest length from the longest length. Okay, so if we go back to our chart here, the reason why you do this line plot is you could see visually like which one pretty easily, which one has the most, right? And you could also see like where they fall in terms of the largest, which is 8/8 and 2/8. Okay, so we need to find the difference between 8/8 and 2/8. Okay, they both have the same denominator, so I can just subtract 8 minus 2 over 8 equals 6/8. Okay, but this is not in simplest form. So if I divided each of these by 2 over 2, 6 divided by 2 is 3, and 8 divided by 2 is 4. So the difference is 3/4 of an inch. Okay, so the difference between the longest and the shortest bugs in the collection is 3/4 of an inch. Okay, now it says for the guided practice, use the tally chart shown. So the tally chart represents the width the widths of buttons collected by Bella's mother. Represent this data in a line plot, okay? So if you look here at 1/8 of an inch, we have 5 plus 1 more is 6. So above the 1/8 on the line plot, we're gonna put 6 X's. 1, 2, 3, 4, 5, 6. Okay, I don't have any at 2/8, but at 3/8 I have 3. So above the 3/8 on the line plot, I'm going to do 3 X's. 1, 2, 3. Okay, we have 1 at 4/8 of an inch. So 1 X above the 4/8. And you see how you try to kind of make them even as you go across in a line so you could see it visually a little bit better. 5/8 of an inch, we had 2. So 2 X's above that. And at 7/8 of an inch, we have 1, 2, 3, 4. So nothing at 6/8, but at 7/8, I have 1, 2, 3, 4. Okay, so your line plot should look like that. Okay, so then it says that suppose the buttons that were 3/8 of an inch wide were laid in a row touching. How far would the row extend? Okay, so 3/8 up here, we have 1, 2, 3. So I can just add those together. 3/8 plus 3/8 plus 3/8. They all have the same denominator, so I could just add across. 3 plus 3 plus 3 is 9/8. Okay, so if you remember from our fractions chapter, this is an improper fraction. An improper fraction is when the numerator is equal to or bigger than the denominator, okay? So you have to change this into a mixed number, which is a whole number and a fraction, okay? So one way to do this is to think how many eighths can I take out of this 9/8, okay? Because 8 over 8 is 1. So if I subtract 8 over 8, which is 1, I would be left with 1/8. So I would have 1 and 1/8, okay? So 9/8 is equal to 1 and 1/8, okay? Now you might remember that the way we can turn a mixed number into an improper fraction is to multiply the denominator, apply the whole number, and then add the numerator, right? So 8 times 1 is 8, and 8 plus 1 is 9. So this is correct, okay? So it says, how far would the row extend? It would extend, might be a little confusing for you there, my little multiplication and addition there. Okay, so it would be 1 and 1/8 inches. Okay, the other way you can turn this improper fraction into a mixed number is to divide, right? 9 divided by 8, okay? So here's the other way we could do it. How many times does 8 go into 9? It goes in 1 time. 1 times 8 is 8. I can subtract, and I'm left with 1. I can't bring down any more numbers. So you could take this remainder and put it over the divisor, and I would get 1 and 1/8. The same way here. Okay, so either way, whether you want to take out each whole number and see how much of a fraction you're left with, like we did down here, or you could always divide, okay? It's gonna be a little bit different than what we've done in the past. Okay, now this says, here's the independent practice. So if you would like to do this on your own, stop the recording and try this on your own. Please do that. Okay, but we're going to go over the answers now. Okay, so this says the frequency table represents fractions of an hour Sonia studied each evening over the last 12 days. Represent this data in a line plot. Okay, so what I would do here is I would go one by one, and I would put like a little slash through it to make sure that I am accounting for it here and I'm putting it here, right? So you start out with 1/4 of an hour. So I'm gonna put an X over here. And I might do a little line through it like that. Then I have 3/4 of an hour, put an X here, line through it. 1/2 hour, put an X here, line through it. 1/4 hour, another X over that, cross it out. 1/2 hour is the same as 2/4, right? So cross that out. 3/4 of an hour is here. Cross that out. 1/4 of an hour is here. Cross that out. 1 hour is 4/4. 1 hour, 1/2 hour, same as 2/4. That goes there. 1/4 of an hour, another x over the 1/4. 3/4 of an hour, another x over that. And 1/2 hour, another x over that. So you could see visually here that there's the same number of 1/4 hour and a 1/2 hour. Okay, a little bit less 3/4 of an hour, and then a 1 hour. Okay, there it is in the line plot. Okay, so now they want to use this information, this data, to do some interpretation. Okay, so it says, which time interval was least frequent as a study time for Sonia? And be able to explain. If I look at my line plot here, I only see 1x over the 1 hour, right? So we just have to say that. So we're gonna say the 1 hour, these are time intervals. 1 hour time, sorry, that's kind of sloppy, interval, okay? Then we have to explain. We could say there is only 1x above that marking on the line plot. Okay, so there's our answer and our explanation. Okay, I can see that there's only 1x here, so I know that's the least. Okay, the next question 5 says, what is the difference in the total time spent studying during the 3/4 hour time intervals and the 1/4 hour time intervals? Okay, so this one I think we need a little bit more room, so I'm going to write this on a separate piece of paper. I have a lot of eraser shavings here. Okay. So if we look at the 3/4 hours, it's 1, 2, 3, right? So I could just take 3/4 and I could times it by 3, okay? And I can turn that into a fraction, right? 3 over 1, so I could just multiply across. 3 times 3 is 9, and 4 times 1 is 4. Okay, so again, there's 2 ways that you can now turn this improper fraction into a mixed number. I can take out 4/4, which equals 1, and I would be left with 5/4. Okay, so that would be my 1 here. Okay, ooh, look, I could take out another 4/4, and I would be left with 1/4. Okay, so this 9/4 can be written as an improper fraction, 1, 2, and a 4th. Okay, the other way I can figure this out is to take 9 and divide it by 4. 4 goes into 9 2 times. 2 times 4 is 8. I subtract, I get 1. I have no other numbers to bring down, so I take this remainder and I put it over the divisor as a fraction, and that's also 2 and 1/4. Okay, so this is the number of times at the 3/4 of an hour, okay? It would be 2 hours, and 1/4 of an hour, right, would be 15 minutes, okay? Now they want to know what the difference is though between the 3/4 of an hour and the 1/2 hour intervals. Okay, so 1/2 hour is also 2/4 is 1, 2, 3, 4. Okay, so to be consistent, why don't we use the 2/4? Okay, so 2/4, because we had 4s in the denominator here, times 1, 2, 3, 4. 4 over 1, I can write it as a fraction, equals 8/4. Okay, how many times does 4 go into 8? That's equal to 2. Okay, now they want us to figure out the difference between the two of them. Okay, so if you do it up and down like any other subtraction problem, I think it's much easier. So 2 and 1/4 minus 2, and there's no fraction part of this one, right? Okay, so first I can subtract the fractions. I have 1/4, but I'm not subtracting anything from it, right? 2 minus 2 is 0, okay? So the difference is going to be 1/4 of an hour. Okay, and that is what I'm going to write on the line. 1/4 of an hour difference. Okay, there's that answer. Okay. Now it says, what is the total time Sonia spent studying over the last 12 days in minutes, and what is the equivalent time in hours and minutes? Okay, So I think it's easier to figure out the hours and the minutes first and then convert it to all minutes. Okay, so we need to take this 1/4 of an hour, and I have 1, 2, 3, 4 times, so I'm going to times it by 4 over 1 is equal to 4 fourths, which is equal to 1 hour. Okay, and that makes sense because if you think of, you have 4 15-minute intervals on a clock, right? That would be equal to 1 hour. Okay, now we have 2 fourths of an hour times 1, 2, 3, 4 times 4 over 1 equals 8 fourths, and 8 divided by 4 is 2 hours. Okay, now we have 3/4 of an hour, and I have 1, 2, 3. So 3 fourths times 3 over 1 equals 9 fourths. And if you remember, we said that equals 2 and 1/4. 4 times 2 is 8, plus 1 more is 9 fourths. Okay, 2 and 1/4 hours. Okay, and then I have just 1 hour here on my chart, right? Okay, so we can just add these up. Okay, this is the only fraction I have, 1/4. 1 plus 2 is 3, plus 2 more is 5, plus 1 more is 6. 6 and 1/4 hours. Okay, now we can put it into, it says hours and minutes, right? So 1/4 of an hour, how many minutes is that? Well, that is 15 minutes, right? So, because if you have a clock, which I don't have handy right now, you would see that, 5, 10, 15 is 1/4 of an hour, right? Because a clock, if I were to divide it like this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So it'd be 1, 2, 3. So 5, 10, 15 minutes, okay? So our first answer is going to be 6 hours, 15 minutes. Okay, now it says how many minutes total. Okay, so now we have to multiply 60 minutes in an hour times 6 hours is going to be 6 times 0 is 0. 6 times 6 is 36. Okay, plus have an additional 15 minutes. Add those together. 0 plus 5 is 5. 6 plus 1 is 7. And a 3. Okay, so this is 375 minutes. Okay, hopefully that makes sense. If you were wondering too about the 1/4 of an hour, you could also do it this way, right? There are 60 minutes in an hour times 1/4. Okay, so that'd be 60 over 4. We do it this way. 4 goes into 6 one time. Minus 1 times 4 is 4. 2, I bring down my 0. 4 goes into 25 times. 5 times 4 is 20. Get 0. There'd be another way to come up with that 15 minutes. Okay, hopefully that makes sense. All right, last page. It says, every time one of Quinn's pets needed its water filled over the past week, he marked the amount of water given in a table. So here's his table. Represent the data on a line plot. So he has a hamster and a dog and a rabbit and a cat. Okay, so he has a very busy house and a lot of pets. Okay, the first thing we have to do is set this up like a ruler, right? This line plot, okay? So it looks like these are all divided into eighths, right? So on one end, we're gonna have a 0. On the other hand, we're gonna have a 1, which is 8 over 8, right? Or 1, okay? If I divide this in half, okay, this would be 4/8 or 1/2, okay? Running out of room there a little bit. Okay, and then if I divide each of these into eighths, okay, 2/8 is equal to 1/4. Then I have 5/8 and 6/8 and 7/8. That's a sloppy H right there. me fix that. Okay, hopefully you can see that, okay? So we divided this into from 0 to 1, and we've divided it into eighths. Okay, now I can start putting my x's in. Okay, and like that other problem we did, I think it helps to, like, once you do it, to mark it off. So I have 1/8, so I put an x over here, cross it out. Dog gets 1 cup, put an x over the 1. The hamster gets 2/8. 1 over the hamster gets 2/8. Rabbit, 1/8. Another x over the 1/8. 2/8 for this rabbit. Another x over 2/8. Hamster, 1/8. Put another x over there. The cat, 4/8. The x there. Dog again, 1 cup of water. Cross that out. 5/8 for the cat this time. Dog, another 1 cup. Okay, the rabbit, 1/8. And the dog, 6/8. Okay, so our line plot would look like this. Okay, just checking to make sure that I did this right. I did on the slide. Okay, now it says, what is the difference between the smallest amount of water and the greatest amount of water Quinn gave to his pets over the week, and explain. Okay, so we have 1 cup, right, is the most, and 1/8 is the least. Okay, so I'm going to make this 8 over 8, so I have a like denominator, so I can just subtract the 1/8, right? I have a like denominator, so I can just say 8 minus 1 is 7/8. Okay, so we're going to say for the answer for number 8 is 7/8 cup is the difference, right? And I explain it by saying 8 over 8, just what I did here, minus 1/8 equals 7/8 cup. Okay, there we go. Next one, how much more water did the cat get than the hamster over the course of the week, and explain. Okay, so we are going to have to figure out, first of all, the cat. Let's see, the cat gets, you have to kind of look through this chart now here, 4/8. Here's a cup here. Cat again gets 5/8. And that's it for the cat. Okay, so then the cat gets 9/8 cup of water. Okay, here's the cat. Alrighty, now we need to figure out the hamster. Hamster gets, so there's the hamster. He gets 1/8 cup. Hamster, hamster. Here's another hamster plus 1/8. Looking for the hamster again. That's it. Is that right? Or did I miss one? I think that's it. Oh, I did miss one. Here's another hamster plus 2/8. Sorry about that, folks. Okay, so 1/8 plus 1/8 plus, all like denominators, I can just go across as 4/8. Okay, now it's asking me for the difference, right? So I'm gonna leave this as eighths because this is eighths to make it easier to subtract. So 9/8 minus 4/8 equals 5/8 cup is the difference. Okay, so the cat gets 5/8 cup more water than the hamster. Okay. Now, number 10 says, explain to a friend the similarity between the number lines on a line plot and the markings on a ruler. Draw models to illustrate your answers. Okay, well, here's a ruler, right? And you can see that this is very similar, right? So, why don't we just say both the line plot and ruler are divided into parts. Okay, so we could just do, let's make an easy one. 0, 1/2, 1. This could be a line plot, probably not gonna have a 0. Right, we do that is the line plot, and then here's the ruler, right? 0, 1, and that's also gonna have a 1/2 inch. Okay, because it said to draw models to illustrate. So there we go. Okay, finally, it says line plots can be displayed. this answer is. Okay, line plots can be used to display measurement data. Name another way to display measurement data. So in the past, you probably have done like pie charts and bar graphs, but what did we do at the very beginning of the lesson? Let's just write this down. What do we call this? This, we said, was a tally chart. So let's just write that. Another way to do it is a tally chart. And that, my friends, is the end of this lesson. Okay, so dial in at 11 if you have questions about math. Hopefully we'll finish our how-to before then, and so we can stay on schedule. And you have to do the homework on pages 747 and 748. Okay, bye-bye, my friends.